Find the determinant of the following matrices below. Take down solution. Then you must take note, we can only find the determinant of square matrices. A square matrix is simply a matrix in which the number of rows, these are the rows, they run horizontally, and the columns, they are equal. For example, the matrix A, it has 1, 2, 3 rows and 1, 2, 3 columns. For us to find the determinant of a matrix, for example, if we have the matrix A equal to the first entry small a, next entry B, next entry C, D. The matrix A is of order 2 by 2. For us to find the determinant of this matrix, which is denoted as such, A within 2 bars, which is the same as writing the matrix A in between 2 bars, like this. The determinant is simply equal to, we take the product of the entries on the leading diagonal, that means A times D, minus the product of the entries on the alternate diagonal, take B times C. Now, if we have a matrix A, which is a 3 by 3 matrix with entries A, B, C, D, E, F, G, H, I, the determinant of this 3 by 3 matrix is different from that of a 2 by 2 matrix, and we calculate the determinant of a 3 by 3 matrix by making use of the formula below. I'll write down the formula. We make good use of the following sign rule. The matrix is a 3 by 3 matrix. Make use of this positive. This first entry is positive, the next negative, the next positive. Moving down to the second row, the first entry negative, the next positive, the next negative. Moving down to the third row, positive, negative, positive. We make good use of this. Now, let's write down our matrix A, which is A, B, C, D, E, F, G, H, I. The determinant of this matrix A, which is a 3 by 3 matrix, is simply equal to, we are going to make good use of this sign rule you see here. It tells us that if we are using the first row, the sign has to be positive. We take A times the determinant of the 2 by 2 matrix, which is formed when we suppress the column having the entry A and the row having the entry A. You'll see we'll be left with this 2 by 2 matrix. The determinant of this matrix E, F, H, I, plus the cofactor of the entry B. According to the sign rule, it is minus. That means we are to have a negative sign here, minus B times the determinant of the 2 by 2 matrix, which is formed when we suppress the column and the row having the entry B. We'll be left with this matrix D, F, G, I, plus the cofactor of the entry C, which is obtained by taking C, according to the sign rule, is positive. C times the determinant of the 2 by 2 matrix, which is formed by suppressing this column and this row, that is D, E, G, H. This is simply equal to A times E times I, which is EI, minus F times H, minus B times D times I, ZI, minus F times G, plus C times D times H, which is DH, minus E times G, which is EG. By making use of this formula, we can find the determinant of the following 3 by 3 matrices. We take the first one for question I. We have to find the determinant of the matrix A, which is equal to 1, -2, 1, 2, -1, 3, 0, 2, 1. The determinant of the matrix A is simply equal to, by making use of this our formula, we need the cofactor of the entry 1. This will give us 1 times the determinant of this 2 by 2 matrix, which is from -1, 3, 2, 1, minus the cofactor of the entry -2. We take -2 times the determinant of the 2 by 2 matrix, which is from 2, 3, 0, 1, plus the cofactor of the entry 1, which is 1 times, suppress this and this, 2, -1, 0, 2. You know this negative becomes addition. This will simply be equal to 1 times the determinant of this 2 by 2 matrix is simply -1 times 1, which is -1, minus 3 times 2, which is 6. These negative signs become positive, plus 2 times 1 remains 2, minus 3 times 0, which is 0, plus 1 times 2 times 2, which is 4, minus -1 times 0, which is 0. This will simply be equal to 1 times -1 minus 6 gives us -7, plus 2 times 2 minus 0, which is 2, plus 1 times 4 minus 0, which remains 4. This will simply be equal to 1 times -7 gives us -7, plus 2 times 2, which is 4, plus 1 times 4, which is 4. This will simply be equal to -7 plus 4. It gives us -3. -3 plus 4 is the same as 4 minus 3, which is 1. Therefore, the determinant of the matrix A, this matrix, is simply equal to 1. Now let's go to 2i. We have to find the determinant of this matrix B with entries 1, 3, 2, 3, -1, 4, 2, 1, 3. The determinant of the matrix B, which is B in between two bars, is simply equal to, in this case, we are going to make use of two different approaches. We are going to make use of the first rule when calculating the cofactors. Then we are also going to make good use of the first column to calculate the cofactors. Then at the end, we are going to notice that the results will be the same. For this case, let's start by making use of first rule. This will give us, we need a cofactor of 1. It is simply 1 times the determinant of the 2 by 2 matrix, which is formed by suppressing this column and this row, -1, 4, 1, 3, minus 3 times the determinant of the 2 by 2 matrix, which is formed by suppressing this column and this row, 3, 4, 2, 3, plus 2 times the determinant of the 2 by 2 matrix, which is formed by suppressing this column and this row, 3, negative 1, 2, 1. This will simply be equal to 1 times negative 1 times 3 gives us negative 3, minus 4 times 1, which is 4, minus 3 times 3, which is 9, minus 4 times 2, which is 8, plus 2 times 3 times 1, which is 3, minus negative 1 times 2, which is negative 2. This is simply equal to 1 times negative 3 minus 4 gives us negative 7, minus 3 times 9 minus 8, which is 1, plus 2 times 3 minus negative 2 is the same as 3 plus 2, which is 5. This will simply be equal to 1 times negative 7 gives negative 7, minus 3 times 1, which is 3, plus 2 times 5, which is 10. This is simply equal to negative 7 minus 3 gives us negative 10. Negative 10 plus 10 gives us 0. This is for the first case when we make use of the first rule in calculating the cofactors. Now let's see the second case where we make use of the first column to calculate the cofactors. We are going to obtain the same result. First, we are going to start by writing down the sign rule again. Remember, 3 by 3 matrix when calculating the cofactors: positive, negative, positive, negative, positive, negative, and lastly, positive, negative, positive. We have our matrix A. Now in this case, we have the matrix B to be equal to 1, 3, 2, 3, negative 1, 4, 2, 1, 3. The determinant of the matrix B is simply equal to, we are going to calculate the cofactors by making use of the first column. This is the sign rule for the first column. That means we have to use this column. For the first entry, we need the cofactor of 1. According to the sign rule, it is positive. Take 1 times the determinant of the 2 by 2 matrix, which is formed by suppressing the column which has 1 and the row which has 1. Gives us negative 1, 4, 1, 3 as the 2 by 2 matrix. We move now to the next. The sign rule says it is negative plus negative 3 times the 2 by 2 matrix, which is formed by suppressing the column and the row which has the entry 3. We know positive, negative stays. We write down minus 3 times suppressing this and this. We're left with 3, 2, 1, 3. Plus the sign rule says it is positive 2 times the determinant of the 2 by 2 matrix, which is formed. Suppress this and this. We will be left with 3, 2, negative 1, 4. This will simply be equal to 1 times negative 1 times 3 gives us negative 3, minus 4 times 1, which is 4, minus 3 times 3, which is 9, minus 2 times 1, which is 2, plus 2 times 3 times 4, which is 12, minus 2 times negative 1, which is negative 2. This will simply be equal to 1 times negative 3 minus 4 gives us negative 7, minus 3 times 9 minus 2, which is 7, plus 2 times 12 minus negative 2, which is the same as 12 plus 2, gives us 14. This will simply be equal to 1 times negative 7 gives us negative 7, minus 3 times 7, which gives us 21, plus 2 times 14, which gives us 28. This will simply be equal to negative 7 minus 21 gives us negative 28. Negative 28 plus 28 gives us 0. You can see the determinant is the same as for the first case, which we calculated the cofactors by making use of the first row. You can see the results, they are the same, 0, 0. This is how we calculate the determinant of any 3 by 3 matrix. We are done with the solution of this question. If in case you have any doubts, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.